Okay, we're getting ready to take factoring to the next level, and we're going to factor trinomials that do not or without a first term coefficient. I want you to understand what that means. A trinomial without a first term coefficient is right here, okay, and here. There's no number in front of this variable, so there's no coefficient, and these are trinomials. Trinomials with no first term coefficient. Okay? This is all the notes right here, but this is going to need to be practiced a lot. All right? The way we do that, we're going to find two integers, okay, meaning they could be positive or negative, whose sum is equal to b, which is this number, and whose product, the two integers are going to multiply to be c. Because b and c are going to be numbers like you see here. Okay, no first term coefficient. The numbers are going to be, the two integers that we find are going to add to be b, the sum will be b, and they're going to multiply to be c. The product of those two integers are going to multiply to be c. All right. Now that's tricky enough, but these signs in the middle or in between these terms are going to play a part as well, and which is going to make it a little bit confusing and a little tougher for you guys. All right, you're really going to have to use some problem solving and really be thinking and focusing when you're practicing these. When they're both positive, okay, they're going to multiply to be a positive 8. They're going to add to be a positive 6. Those are the easiest ones, okay? Again, our answer is going to be a binomial times a binomial. And it's going to equal this trinomial, all right? What multiplies to bx squared? X and x. All right, now, what is going to multiply to be 8 and add to be 6? I realize some of you can do that in your head. Others may need to see the factors, and then as they get bigger, you're going to need to see the factors. So here's the factors of 8. Which factor pair adds to be 6? 2 and 4. All right? And again, these multiply to be a positive 8, and they add to be a positive 6, so they're positive 2 and positive 4 are our numbers. And then this is our answer. You guys have multiplied binomials, and most of the time you got a trinomial as your answer. So the way to check this would be FOIL or box, and it should multiply to be this trinomial. So we're basically doing the opposite of multiplying. We're factoring. We're finding what multiplies to be this trinomial. All right, this one's a little trickier. Okay, it is going to be a binomial times a binomial. There is no first term coefficient, or it's understood as 1. There's no GCF here. They don't all have an X. We cannot forget our GCF because that's going to come into play again. So we're finding the factor pair that will multiply to be negative 18 and add to be negative 7. It's still going to multiply to be C and add to be negative 7. So we're looking at the factors of 18. 1 and 18, 2 and 9, 3 and 6, and nothing is adding to be 7, okay? But look, it's a negative 7. And this needs to multiply to be negative 18. The only way we're going to get a negative is if we multiply a positive and a negative. That's the only way. So one of these factors is going to be positive and one's going to be negative. And instead of thinking it's going to add to be 7, let's think it's going to subtract to be 7 because of this minus. It's going to subtract to be 7. Here's the pair of numbers that subtract to be 7, but not 2 minus 9, it's 9 minus 2. So where do we put the numbers in order for it to work out right? I want it to add to be a negative 7, so the bigger factor is going to get the sign that's in your middle here. My bigger factor is 9. And I should have put the x's here. So let's check it. X times x is x squared. Negative 9 times positive 2 is negative 18. And negative 9 plus 2 is negative 7. They multiplied to be the negative 18. They added to be negative 7. Notice that the two minuses did not come down. That's a common mistake. Students think they just put the two minuses here. But it doesn't. It has to multiply to be C. The product will be C. It has to add to be the B term. The sum is equal to B. Okay, there's your answer. Again, these are a little trickier. You're going to spend a lot of time practicing them. All right, let's look at class example 3. There's no first term coefficient. They do not all have an x. There is no GCF. So we go straight to a binomial times a binomial. We can split this x up. X times x is x squared. I have a negative third term, so it has to multiply to be a negative. Anytime you have a negative third term, your signs are going to be a plus and a minus. So your factors of 8 that are going to subtract to be 2. The factors of 8 that are going to subtract to be 2. And the reason I'm saying subtract is because one factor is positive and one's negative. So you want to subtract them to be 2. So 1 and 8, 2 and 4. All right, which ones subtract to be 2? Now, where do we put them? The one in the middle, whatever sign is in the middle, gets the bigger factor. Whatever sign is in the middle gets the bigger factor. The bigger factor is 4. The 4 goes with the plus. Now, let's check it. Does positive 4 and negative 2 multiply to be negative 8? Does positive 4 plus negative 2 add to be positive 2? Yes, it does. Okay, look at this next example. When you see both positives here, those are the easier ones. You know they're both positives. If it's gonna multiply to be a positive and the middle term is positive, then both terms are positive. Split the x's up. There's no GCF. They don't all have an x. I'm looking for the factors of 8, multiply to be 8, that add to be 9. 1 and 8, 2 and 4. Here they are. And since my middle term is positive, and my last term is positive, that one is the easier one. So they multiply. Positive 8 times positive 1 is positive 8. And positive 8 plus 1 is positive 9. All right. I'll do another example with you. There's no first term coefficient, so there's no number GCF, and they do not all have an x. So I go straight to my parentheses, my binomial times my binomial. And like I said before, when they're both positive, that's the only time you bring the signs down. So we're looking for the factors of the 15 that add to be 8. 1 and 15, 3 and 5. Here they are. And since they're both positive, it doesn't matter where I put the 3 and the 5. So positive 3 times positive 5 is 15. And positive 3 plus 5 is 8. That's my quick check right there. They multiply to be the third term. They add to be the middle term. I'm going to leave student example 1 for you because it's very simple. It's very similar to 5 and 4 with the signs. It's just going to be, I'll start it for you. You know, you're going to have a plus. You're finding the factors of 12 that add to be 7. All right, but let's flip it over and do what I think it might be a harder one back here. All right. Let's look at student example 2. There's no first term coefficient. Okay, they do not all have an x, so there's no GCF here. Nothing to factor out. You always need to be able to look at that because there may be GCFs thrown in soon as well. All right, we split our x's up. X times x is the x squared. I have a positive n term. Okay, so remember when we multiply, in order to get a positive product, the signs have to be the same. But the only way I'm going to add them to get a negative, in this case, if the signs are going to be the same, they're going to have to both be negative. So let's look at the factors of 27 that are going to add to be 12. 1 and 27, 3 and 9, and these are the ones that add to be 12. All right, so 9, it doesn't matter where I put the 3, where I put the 9. But how am I going to, so 9 times 3 is 27. We said the signs can either both be negative, and negative 9 times a negative 3 is positive 27. But how am I going to get them to add up to be negative 12? They're both going to be negative. Okay, negative 9 times negative 3 is positive 27. And negative 9 plus negative 3 is negative 12. All right, you're going to turn it over and do the one that we didn't do. That's student example 1 right here. Okay, and I want you to do 3 and 4, and we're going to go over those. But before you do that, I'm going to give you a little guide here that I want it to be in your notes, but I'm probably also going to put it on the board for you as well. So let's look at x squared plus bx plus c. When we have a trinomial with the signs that look like this, our binomial are going to both be positives. Okay? When we have a trinomial, oops, make this be x squared minus bx plus c. All right, the middle term is negative. When the middle term is negative but the end term is positive, our signs are going to both be negative. We're going to find the factors of c that add to be b, the factors of c that add to be b. All right, this is when the signs are the same. The trickier part is when the signs are different. Okay? So let's look at how those trinomials look. X squared plus bx minus c. Anytime your third term is negative, your signs are going to be different. Because that's the only way you get a negative, is when you multiply a positive and a negative, right? So how do you know where to put the factors? Well, the factor pair is going to subtract to be b. Remember, because they're going to be different signs. So they're going to subtract to be b. Whatever the sign is in the middle, the bigger factor goes with that sign. So the middle factor here is a positive. So we're going to put b for big. The bigger factor is going to go with the positive. And again, as we practice this, this will be more useful to you. X squared minus bx minus c. That doesn't mean you bring down two negatives here, because you have a negative third term. The only way you're going to get a negative answer when you multiply is if you have a positive and a negative. So we're going to have, I'll put a minus here and a plus here. They're going to multiply to be a negative and subtract to be this. Because the middle term is negative, your bigger factor, your bigger number, will go with the negative. All right, these are the harder ones when there's a negative end term. The signs are going to be different. When there's a positive end term, the signs are the same. Whatever's in the middle is what they both are. That is going to be key. When you're doing a multiple choice test, you can eliminate if you know this right here. I'm going to put this on the board. I'm going to refer to it a lot. This is going to help you tremendously with factoring. All right, do those student examples. Raise your hand if you need some help or if you need to get it checked when you're finished.